All right, and we are recording. Okay. So we actually have a short week this week because we have a flex day. So we're actually going to have a couple of quizzes this week. I was going to give you another quiz today, and you shouldn't think of it as being, quote unquote, more difficult. It's in order to raise your grades, some of your grades, to get them a little bit higher. All right, I'll be going over the quiz last time. It was a little bit more difficult, and I know some of the scores weren't as high, so that's the reason why I'm planning to give you another quiz today during the second half. And so as usual, you'll help each other out, and then Star and Mackenzie and I can come help you as necessary. All right, so I was just about done with 9.5. I'll finish 9.5 today. Your quiz is going to be on 9.5. Let's see, what am I doing here? Yeah, so this Thursday is going to be a flex day. So there's no class. I'll give you another quiz on Wednesday. Okay, and our exam is going to be on Thursday the 29th. Okay, so here's the coverage, 9.1 up to 10.2. And I'm just realizing, yeah, on my original schedule, yeah, this is all mixed up now. Okay, so I'll go ahead and put what the game plan for now is. Finish 9.5 and start 10.1. So I hope I can finish 10.2 probably today. So 9.5, 10.1, maybe 10.1 here, and at least finish 10.2 by Wednesday. Okay, so I'm gonna give you another quiz today and another quiz on Wednesday. Wednesday is the last day of the week. I know it sounds weird to say that, but we normally finish on Thursday, but there's no class on Thursday. Okay, so again, next week, I will get started on our last chapter, but the exam on Thursday the 29th will just cover 9.1 and 9.5, which I'll finish 9.5 today, and 10.1 and 10.2, okay? Right, so any questions about that? So you're gonna get two quizzes. If maybe the easiest way to say it is the only day you're not getting a quiz this week is tomorrow. I'll give you another quiz today. It's just to raise your average mostly, and then another quiz on Wednesday, hopefully, okay? So anybody have any questions? You can put it in the chat or unmute yourself. Otherwise, I'll go ahead and get started. Okay, I don't see or anything. So, okay, I do want to go over the quiz from last time because not everybody got it right. Even when you were working in a group, it's a little bit more difficult. So let's go over this a little bit. Okay, so find the value of sine of 75 degrees in two ways. Okay, more of you got number 2 correct than number 1. Okay, so for number 1, half angle formula, sine of 150 degrees divided by 2 is equal to square root of 1 minus cosine of 150 degrees over 2. Okay, this comes out to be negative radical 3 over 2. So 1 minus a negative radical 3 over 2 divided by 2. Okay, and then to clean that up, we know that's going to be a double negative, so that's a positive. Multiply the top and the bottom of the radical by 2 over 2. So the bottom just becomes 2. Inside becomes 2 plus radical 3. So square root of 2 plus radical 3 divided by 2. You didn't have to write this, but it's about 0.9659. I guess it's just for assurance that if you actually did the sine of 75 degrees, it was 0.9659. And I mentioned that to you on Friday also. Okay, and the other way to get the sine of 45 degrees that I wanted to do was the sine of a sum, sine of 45 degrees plus 30, which is sine of 45 degrees, cosine of 30 degrees, plus cosine of 45 degrees, sine of 30 degrees. So both sine and cosine of 45 degrees is radical 2 over 2. Cosine of 30 degrees is a half. Sine of 30 degrees, sorry, actually I have this reversed. This should be radical 3 over 2, that's a half, but you get the same answer. So radical 2 plus radical 6 over 4, which is also 0.9659. Okay, so I should see this and this. Okay, and again, put all these on your next cheat sheet for the test next Thursday, right? Especially there was that one page that had a whole bunch of the identities, right? See if we can find where that was again for you. So again, if you haven't already done so, put it all down. It was on page number 616. Okay. And again, maybe I'll just show it to you if you haven't already seen it. But I'm pretty sure I had it on previous videos. Put as many or all of these as you feel like putting down on your next cheat sheet. And there we go. And those aren't the only ones, by the way, as I mentioned before. There's more. Okay. All right, so that was the quiz. So not everybody did, full credit on that one. So I was going to give you another one today based on today's material. Okay, so I'll finish 9.5. I think I did 25 and 27. I'll show you how to do 29, 31, and 33. And the quiz I'm going to give you today is going to be very much like that. Okay, and then we're done with the section. Okay, so we'll just knock them all off. 29, cosine of inverse sine of 2/3. So 9.5 from 29, page 653. Cosine inverse sine of 2/3. All right, you can do this without the triangle, but I think more of you are more comfortable with the triangle method. So I'll approach it from the triangle method. And so I want you to get comfortable with this. And I think you're probably better with this on the quiz anyway. Okay, so the quiz that I'm going to show you today is going to be almost exactly like this. So be ready for that. Okay, so this thing here, call it theta, which ultimately means you're trying to find cosine of theta, right? Okay, so I'm going to write inverse sine of 2/3 is theta. Theta is inverse sine of 2/3. Okay, write the same thing without the -1. Okay, so I'm taking the sine of something. Does it seem reasonable that I'm taking the sine of 2/3? No, I'm taking the inverse sine of 2/3. So I must be taking the sine of something else. What else is there? Theta. Sine of theta is 2/3. Okay, then we do our SOHCAHTOA. SOHCAHTOA. I think most of you are okay with the SOHCAHTOA stuff. So draw myself a triangle. Obviously, the triangle doesn't have to be the scale, so don't worry about the scale. So, oh, this one's supposed to be bigger. Don't worry about that. And call this theta. All right, sine. Sine is opposite over hypotenuse. So opposite to hypotenuse 3, right? And now the adjacent, I'll do some a squared plus b squared equals c squared, right? So that doesn't look too bad. X squared plus 2 squared equals 3 squared. 2 squared is 4, 3 squared is 9. X squared plus 4 equals 9. Subtract 4. X squared equals 5. Take the square root. So x is radical 5. So I'm going to sneak in here now. Radical 5. Raise it up for you. All right, so now what am I trying to find? Cosine of theta, right? That's why I write it down, okay? you might not need it here, but by the time you get into all this heavy duty math here and you say, I forgot, what am I supposed to do again? Oh yeah, find the cosine of theta since I declared this thing to be theta. Okay, so now cosine ka, so ka toa, right? Adjacent over hypotenuse. So radical 5 over 3. And that's my answer, right? So that's pretty much about it. Okay, so one more time. They're going to give me a function and an inverse function all in the same problem. Okay, so I'll call this theta. So I'm going to write down, now what am I trying to do ultimately? Find the cosine of theta. I needed that down here, right? All right, so theta is this. So write down theta is inverse sine of 2/3. Write it without the inverse. So sine of theta is 2/3. Draw my triangle, do my SOHCAHTOA. So I put theta, sine, opposite over hypotenuse. So opposite 2, hypotenuse 3. Do my Pythagorean theorem. X squared plus 2 squared equals 3 squared. This came out to be square root of 5. And what am I trying to find? Cosine theta. So cosine was adjacent over hypotenuse. So radical 5 over 3. Sound good? Okay, so your quiz is going to be just like that. I'll do a couple more of this type and then we're done with this section. Okay. So number 31, similar theme. Sine inverse cosine of 1/3. Theta. So what am I trying to find ultimately? Sine of theta. Okay, so theta is inverse cosine or arc cosine of 1/3. Again, arc cosine and inverse cosine mean the same thing, all the arcs. All right, rewrite it without the -1, without the arc. So cosine of something. Am I taking the cosine of 1/3? No, taking the inverse cosine of 1/3. What am I taking the cosine of? Well, it must be theta. Okay, so draw my triangle. Theta. Do my SOHCAHTOA. Okay, cosine is what divided by what? Adjacent over hypotenuse. So here's my adjacent. Here's my hypotenuse. And I'm trying to find the opposite side. So do my a squared plus b squared equals c squared, right? X squared plus 1 squared equals 3 squared. X squared plus 1 equals 9. I ran out of paper, so I got to go back up. Subtract 1, x squared equals 8, right? So x is the square root of 8. 8 is equal to what times what? 4 times 2, so 2 radical 2. So x is 2 radical 2. So back in my triangle here, I'm going to put this as equal to 2 radical 2. Is that right? All right, now what am I supposed to find? Sine. So sine was what in my SOHCAHTOA? Opposite over hypotenuse. So sine of theta is opposite. So let's see, opposite is 2 radical 2 divided by the hypotenuse, which is 3. So 2 radical 2 over 3. And it's my answer. Okay, problem's finished. I'll just make a little note. You could have done both this problem and the previous problem by doing sine squared plus cosine squared equals 1. So note, also can use sine squared theta plus cosine squared theta equals 1. That would also work. Okay, but I think more of you are comfortable with this. And once you get tangent involved, it's going to be a little bit tougher because most of us aren't as comfortable with the equations using tangent, but you can still do the triangle stuff. Okay, a perfect example of that is the next problem. So in a nutshell, I would suggest for these problems here and for the quiz that I'm about to give you, do the triangle method. I think most of you are more comfortable with that. Okay, so 33 has a tangent. In which case, obviously, you cannot do this very easily. You can do another identity, which would be 1 plus tangent squared equals secant squared, but it's too hard, I think. If you just do the triangle, it works all the time for these kind of problems. Okay, so tangent arc sine of 20 over 29. Okay, this one for sure you can't do sine squared plus cosine squared equals 1, but you can always do the triangle. Okay, and once again, if it says arc sine or inverse sine, they mean the exact same thing. Okay, so when you see that -1 there or there, it's the same as arc. Okay, maybe I'll just show you here. Sine with a -1, inverse sine or arc sine, completely the same. This is easier to write, this is easier to type, right? So we have two options. All right, so just do the same thing. Call this theta. Okay, so ultimately I'm trying to find what? Tangent theta. Oh, I forgot to write the word find. Okay, so find tangent theta. All right, so theta equals arc sine 20 over 29. All right, so write the same thing without the arc. Just sine. Sine of theta. You're not taking the sine of that, taking the arc sine of that. It wouldn't make sense for them to mean the same thing, right? So it must be the sine of theta. Sine of theta is 20 over 29. Okay. Draw my triangle. By the way, I'm always drawing my triangles like this because I'm used to it. You don't have to make your triangle look like that. Okay. I mean, if you want to make it look like that or whatever, you know, scratch paper. If you like triangles that look like that, or you like it looking like that, or like that, it's okay. Same. Actually, they are equivalent, right? If you just turn the paper, then you get this, right? Say, well, I like it to look like that. It's the same thing. Just turn the paper. Or I want it to look like that. It's fine. Just I always go like this, but you don't have to. If you like your triangles to look like that or like that, well, they have to be right triangles right now, which actually is a good introduction. The next chapter on trig, we're going to be dealing with triangles that are not necessarily right triangles. Okay, but we can still do some trig on it. All right, do my SOHCAHTOA. So opposite is 20, right? Hypotenuse is 29. SOHCAHTOA, right? Sine is opposite over hypotenuse. Opposite over hypotenuse and adjacent. Oh boy, these numbers aren't as nice, right? So x squared plus 20 squared equals 29 squared. So punch it in your calculator. X squared, well, I don't think I need a calculator for 20 squared. That's 400, right? But 29 squared, punch that in your calculator, get 841, right? Subtract 400. X squared equals 441. Hit the square root button. X comes out to be 21. Okay, so this is 21. Is that right? All right, so what am I trying to find? Tangent theta. Okay, so SOHCAHTOA, tangent is what over what? Opposite over adjacent. So opposite is 20. Adjacent is 21. So there we go. Tangent theta is 20 over 21. And I am now done with 9.5. Okay, so I'm going to mark off 9.5. So we're completely done with this. So for next week's test, all we have left is 10.1 and 10.2, which I'll finish this week, I think. But if I don't, I still have, next week. And let me do the focusing thing again. And some of you are maybe snickering behind the scenes saying, hey, it looks like he did almost all the homework. That's right. Wanted to help you with as many problems as possible. So when I say the 70% homework requirement, that's almost a joke because I end up doing a huge percentage of the problems. Sometimes I even end up doing 70% or more of the homework anyway, in which case all you got to do is just copy what I did. But of course, you should go home and study it afterwards. All right, so that's that. I'm ready to start a new section. Let me check the chat if anybody has a question. Let's see. Okay. Okay, I'll have to get back to somebody later. Okay, so I'm going to start a new section. So 10.1 and 10.2. And by the way, you might be happy to know this is all we have left for trig is just this. So we've been doing trig for a long time now, quite a bit. Okay, but once we finish 10.2, there's no more trig. The rest of the course is back to pre-calc stuff. Doesn't mean it's easy. It's just not trig for the most part. Okay. Okay, so what's going on now? 10.1. So chapter 10, additional topics in trigonometry. So we're doing 10.1 and 10.2, right triangle applications. Okay, but a buzzword. In a math book, whenever you see applications, do you know what that really means? Hint, if you just look at some of the problems, it means word problems, right? So whenever you see applications, they're trying to hide the fact that you're doing word problems. Okay. But it's just right triangle applications. It's basically SOHCAHTOA. Just got to read all the words, translate those words into a SOHCAHTOA situation. Okay, then all we have left is 10.2, something called the law of sines and the law of cosines. They actually put that in one section. Many books have two separate sections for that. So they cram it all into one, but that's okay. Maybe I can do like law of sines tomorrow and law of cosines Wednesday, perhaps, or something like that. We'll see. We got time. So we're doing right triangle applications. It's still SOHCAHTOA. Sometimes you get a picture. Sometimes you get no picture. Okay, sometimes you get a picture. Sometimes all you get is a bunch of words. Okay, so we have to apply it the right way. Okay, are there any more formulas? Well, yes, there are, and there's actually only one problem involving it. So let me show you this, and you can put this on your next cheat sheet. Formula for the area of a triangle, page 666. So, oh yeah, I already know the area of a triangle, 1/2 base times height. Well, it's not the way that you're used to. So take a look at this picture. The area is 1/2 AB sine of theta. Okay, so if you don't have the height, but you have two sides and the included angle. Okay, so take a look at the picture. You might want to put the picture down also. Side A, side B, angle between them is theta. Area is 1/2 AB sine theta. Okay, so put that in your next cheat sheet. I think you only had one homework problem involving it. Okay, it can be proved by using the fact that the formula for the area of a triangle is 1/2 base times height. You can do a little bit of trig to show it comes out to be this 1/2 AB sine of theta. Okay, in fact, the text goes over that derivation there, top of the page. I won't go over it. You can look at it if you want to, but see that H there? That's the height, right? So to get 1/2 base times height, you do some trig and it comes out to be that. Okay, but I'll show you that when we need it. Okay, so here we go. Page 670, 10.1, the assignment was 1 to 17 odd. Let me double check if that was correct. Yeah, 1 to 17 odd. Okay, so I'll do some before the break, a little bit after the break, and then I'll give you a quiz. But page 670. So for those of you that don't have the book and aren't getting it, it's up to 8. And there's 9. Well, 11 starts there. I think you can read that. But the picture you need is over here. Okay, and there's 13, bunch of words. 15 and 17. Here we go. Okay. Okay, so this is 10.1, page 670. Here's a picture. All right, so triangle ABC, and they tell you some stuff and find some other stuff, right? So 1 and 3 are very similar, so maybe I'll just show you one of those. Okay. I'm going to show you number 1. You do number 3 on your own later. So let me draw the picture that they got. A, B, C, right angle. Okay, question 1. Angle A is 30 degrees. Tell me this is 30 degrees. AB, the hypotenuse, is 60. Find AC and BC. Okay, that makes sense. So let's try to find AC. This is the adjacent side. This is the hypotenuse, right? So cosine of 30 degrees is adjacent AC divided by 60. Multiply both sides by 60. AC is 60 cosine of 30 degrees. Cosine of 30 degrees is radical 3 over 2. Think back to my unit circle. .30-degree angle looks like y is a half. So the x cosine is the other number, radical 3 over 2. So 30 radical 3 centimeters. And let's actually punch that out as approximation. They don't tell you where to round off. Well, number 5, it says round in 1 decimal place. So we'll round in 1 decimal place. So on this regular scientific calculator, you have to go backwards 3 square root. There it is, square root of 3. And then times 30. 51.96. So that we'll round it off to 52.0. Okay, then they ask for BC, that's the opposite side. Here's the hypotenuse. Opposite hypotenuse, sine. Sine of 30 degrees is BC over 60, right? Sine is opposite over hypotenuse. Multiply both sides by 60. BC is equal to 60 sine of 30 degrees. Sine of 30 degrees is a half. I just mentioned that. The y coordinate is a half. So 60 times 1/2, 30 centimeters. Okay. All right, how about I'll do number 5 for you. Angle B is 50 degrees, AB is 15 centimeters. Find BC and AC. Okay, pretty much the same thing. Angle B is 50 degrees. Side note, you don't really need it, but can you tell automatically what does that make this degree? 40, right? 90 plus 50 is 140. All of these have to add up to 180. So this would be 40 degrees. Okay, you don't really need it for this problem, but it's there. I don't know, maybe I'll just write it. Okay, it's in red because that wasn't given, but it was derived. Okay, what else do they tell me? AB is 15 centimeters. It's very similar. All right, so find AC and BC. Right, so here's 50 degrees. This is the adjacent side. That's the hypotenuse. So cosine 50 degrees is adjacent over hypotenuse, BC over 15, right? Cosine is adjacent over hypotenuse. Multiply both sides by 15. BC equals 15 cosine of 50 degrees. Squiggly equals so many centimeters. Okay, so this one has to be done by calculator. This one, make sure you're in degree mode. Okay, I'm in degree mode. This calculator, I'm in degree mode. Okay, this thing up here says degrees, radians, and gradients. Right, so 15 cosine 50. Whoops, 15 cosine 50. 9.6, round it off to the nearest tenth. Okay, do the same thing for AC. So AC is the opposite side. And that's hypotenuse. So sine of 50 degrees is AC divided by 15. Multiply both sides by 15. AC is 15 sine 50 degrees. Squiggly equal so many centimeters. All right, I'll show it to you with the regular scientific calculator. It's a little bit harder, so you folks have to go backwards. So sine of 50 comes first, which you'd have to type 50, whoops, 50 sine. Okay, there it is. And then times the 15. So times 1.5 equals 11.49 means I'm rounding off to 11.5. 11.5 centimeters. And there we go. Okay. All right, so hopefully that's not too bad. Okay. 7, word problem, no pictures. So got to make a picture. Let's see, 7. A ladder 18 feet long leans against a building. The ladder forms an angle of 60 degrees with the ground. Okay, so draw a picture. So here's a building. And the ladder goes up like that. And the ladder is 18 feet long. And this is 60 degrees, right? And of course, we'll make the assumption that it's a straight building. It's not the Leaning Tower of Pisa or something like that, right? Straight up. Hey, how high up the side of the building does the ladder reach? Give 2 forms for your answer, and 1 with radicals and 1 using calculable decimals under 2 decimal places. So what does that mean? That's X. Call that Y. It's part B. Find the horizontal distance from the foot of the ladder to the base of the building. It's Y. Okay, so sine of 60 degrees, SOHCAHTOA, right? Opposite over hypotenuse. X over 18. Multiply both sides by 18. X equals 18 sine of 60 degrees. I might as well just use this picture here. Okay, that's 30 degrees. That's 60 degrees. 60 degrees, it looks like the X coordinate is halfway across the circle. So X is a half, which means Y is radical 3 over 2. So 18 times radical 3 over 2, which is 9 radical 3. Right, so that's the exact value, but nobody says that. I mean, if you were to talk to somebody and say, how high up is the ladder? You wouldn't say, oh, it's 9 radical 3 feet. Nobody talks that way. So you want a decimal approximation also. Okay, and the approximation they asked to within 2 decimal places. 9 times the square root of 3. Okay, so 3, hit the square root button, because that's the square root of 3, and then multiply that by 9. So times 9. 15.59 rounded off. Yeah, we'll put 15.59 feet up. That's how high up it goes. Okay, then the horizontal distance is Y. This is the adjacent side, hypotenuse, cosine. Cosine is adjacent over hypotenuse. After a while, the math for a lot of these tends to be the same. Multiply both sides by 18, right? Y equals 18 cosine of 60 degrees. Cosine of 60 degrees. Look at that 60-degree mark there. What's the X coordinate? If it comes straight down, it looks like I'm halfway across the circle. So it's a half. Nine feet. Right? So that's what we got. So on this picture, 18 feet, 60 degrees. So how high up the side am I going? 15.59. How far is it from here to here? 9 feet. Okay. Okay, problem number 9, they actually give us a picture. So let's look at the picture. 5, 13, and 12. 5, 12, 13. theta. A. Use the inverse sine function to find theta. Express the answer in degrees rounded to 1 decimal place. All right. So sine of theta is what? SOHCAHTOA, right? So opposite over hypotenuse, 5/13. So they want theta to the nearest degree, well, 1 decimal place. So if this is sine of theta, theta is inverse sine of 5/13, which is so many degrees. All right. So second function, right? Second function, inverse sine, parentheses 5 divided by 13. 22.6, let's see, this is round to 1 decimal place, so 22.6 degrees. That's part A. Part B, do the same thing, but inverse cosine function. Okay. Cosine of theta is adjacent over hypotenuse, right? 12/13. So theta is inverse cosine of 12/13. And before I actually do that, what do you think should be true about the answer? I mean, the theta didn't change, right? It's the same angle. You should get the same answer. So I'm anticipating 22.6. Let's try it. Inverse cosine parentheses, what was it? 12 divided by 13. Okay, and I hope I get the same thing. There it is. Every single digit, 22.61986, blah, 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 blah. Okay, one more and then we'll break. C, same thing, but inverse tangent. I better get the same angle. I mean, the angles, that angle doesn't change, right? I should get the same thing. So tangent theta. Tangent is opposite over adjacent, right? TOA. So opposite, 5. Adjacent, 12. So inverse tangent of 5/12. In fact, I'm so confident I'm going to cheat a little bit and just say, I'm putting the answer down so I don't have to pick up my pen again. It better be 22.6, right? So, but now let's actually check it. Second function, inverse tangent, parentheses, 5 divided by 12. And I hope it's 22.6 again. And it is. So notice all three of them are exactly the same. 22.61986, blah, 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 as we expected it to be. Right? Okay. All right, I'll do my focusing thing and then we'll take a break. Okay, so after the break, do a few more of these problems and then I'll go ahead and give you a quiz. That'll be just like, not on this stuff, but the previous section. I'm giving you this and this, and there we go. Okay. All right. So let me see. Caught up with the chat. Yeah, I think we're good. Okay. So break until 12:10 as usual. Thank you.
Here, I'll do it.
Oh gosh. I'll just get it into
Okay, folks, it's time to start up. So I'll do some more problems and then I'm going to give you a quiz. Okay, so it'll be just like the normal quizzes that we have on Thursdays. So I'll put you in your breakout groups. Okay, and then Mackenzie, Star, and I can come around and help you as necessary. Okay, so I'll show you how to do problem number 13. A building contractor wants to put a fence around the perimeter of a flat lot that has the shape of a right triangle. One angle of the triangle is 41.4 degrees and the length of the hypotenuse is 58.5 degrees. For the length of fencing required, round the answer to one decimal place. Okay, so let's just draw a picture of what might be happening here. Okay. I'll draw my triangle like this. Again, you don't have to make your triangles look like this if you don't want to, but I like to. So there we go. Okay, the hypotenuse is 58.5 meters. 58.5 meters. And one angle is 41.4 degrees. That looks like something we had before, but it says find the length of fencing required. So once I finish all the sides, I add them all up. It's the perimeter. And round to one decimal place. Okay. So how about I call that X? I'll call that Y. So let's see. By the way, you may say, can I put the 41.4 here? Yeah, it would work. In fact, you know, if you imagine just turning your piece of paper and then there it is, right? You got what you want. So let's see, opposite hypotenuse, sine, right? Sine of 41.4 degrees is opposite over hypotenuse. Multiply both sides by 58.5. X is 58.5. Sine of 41.4 degrees. And so many meters. And I'm going to round to the nearest tenth, it says. Okay, I'll use both calculators this time. So a regular scientific calculator, if you just have a regular scientific calculator, you folks have to go backwards. So 41.4 first, 41.4, and then hit sine, 0.66, whatever, and then times 58.5, times 58.5, 38.7 rounded off. Okay. By the way, side note, can you find this angle? Right? We need to do that in the next section, but it's just 90 minus that, right? Remember, all three angles have to add up to 180. This is already 90. So between the two of these, it's 90. That's 41.4. So you just go 90 minus 41.4, right? Okay. But we don't really need it here. So Y, oops, too early for Y. But adjacent hypotenuse cosine, right? Cosine 41.4 degrees is adjacent over hypotenuse, Y over 58.5. Y over 58.5. Multiply both sides by 58.5. Y equals 58.5 cosine 41.4 degrees is so many meters. Okay, so I'll use the fancier calculator for that one. 58.5 cosine 41.4. 58.5 cosine 41. Again, if your calculator automatically gives you the left paren, I'll show you. Like if it automatically pops up like that, Some of your calculators do that. Then you close it with the right paren. 43.9. Right? Now it asks for the total fencing. So I just add them all up. Right? So the perimeter is that plus that plus that, right? 15.5, 38.7. So many meters. Five, 38.7, 43.9. 141.1. Okay. So hopefully that wasn't too bad. All right, just do a couple more. 15, they actually give you a picture. Suppose theta is 39.4 degrees. This is supposed to be a roof of a house, I guess. So X is the length of a rafter measure from the top of the wall, top of the roof. Theta is the acute angle between the rafter and the horizontal. H is the vertical distance. Okay, so it's the roof of a home. Suppose theta is blah, 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 whatever. Okay, determine H. Round to 1 decimal place. Okay. Just draw a rough sketch. So theta is 39.4 degrees. And this is also 39.4 degrees. X is 43.0 feet. Find H. Okay. So opposite, hypotenuse, sine. Right? Sine of 39.4 is opposite over hypotenuse. Multiply both sides by 43.0 or 43. 43.0 sine of 39.4 degrees. Round to the nearest tenth. So many feet. Okay, so 43 times sine of 39.4. Make sure you're in degree mode when you're doing this. 43. I decided not to put, 43.0, it's the same as 43 when you type it in a calculator. 27.3, rounded to the nearest tenth. 27.3 feet. It says the gable is a triangular region bounded by the rafters and the attic floor. Find the area of the gable. Round the final answer to 1 decimal place. All right. So how do I find the area of this thing? I have the height. I need to figure this out. which is twice as long as one of these. So how about I'll call this x, but the base is actually going to be 2x, right? So let's go cosine of 39 degrees, or 39.4 degrees, is adjacent over hypotenuse, x over 43.0 multiplied by 43.0. X is 43.0 cosine 39.4. So 43 cosine 39. $33.2. All right, so to find the area, 33.2, that's this. So I double it for this entire base, right? So this is going to be what, 66.4? And the height, we now know to be 27.3, right? All right, so area is 1/2 base times height. And area is square feet. So again, when I worked this out, this was x, that's only half the distance across when I do the trig. Okay, but to get the entire base, I just double it. So I got 33.2, I double it for 66.4. Now I do 1/2 base times height. Okay. $906.4. And how do they want us to round off? 1 decimal place? 906.4 square feet. Okay. B, theta is 34 degrees, H is 36.5. Okay, I'll only do part A because it's different. This time you have to find the hypotenuse. Well, I'm sorry, I'm actually finished with that problem. Never mind. I thought that was part of the same problem, but I guess it isn't. Okay, so I'm finished with that. And sorry, that was actually problem 15. I got the numbers mixed up. It's 15. Yeah, I was about to do 16, but you don't have to do it. Oh well. Okay, 17 and I'm done. And then I'll give you the quiz. And it looks like you'll still have half an hour to do the quiz. Should not take you that long. Okay. Find the area of the triangle. So 3 inches, 2 inches, and 30 degrees. Rough sketch here. That's where you use this new formula, and that's the only place where you use it. Okay, area is 1/2 AB sine of theta. So you multiply the two sides and then times the sine of the angle that's included between them. Okay, so area is 1/2 3 times 2 times the sine of 30 degrees. Sine of 30 degrees is 1/2. And by the way, these cancel out. So I have 3 times 1/2 or 1.5 square inches. That's basically all there is to it. All right, I'm done, folks. So let me do the focusing thing, and then I'll get you set up for the quiz. And I'll show you a sample of that before, because I know Mackenzie, you just joined in, so you can get up to speed as to what the nature of the quiz is like. Okay, but it's a good review for everybody else also. But Mackenzie, I know you may be getting this for the first time. Okay, so that's that. I'm marking off 10.1. Tomorrow I'll start 10.2, which is on law of sines and law of cosines. Okay, but now for the quiz, I'm going to go back and show you 33 from before the break. So Mackenzie, you can see the star. I know you already saw this, but for everybody else, the quiz is going to be just like this, okay? Almost exactly like this. So everybody pay attention to 33 from before the break. This was section 9.5. How I want you to figure out tangent of arc sine 20 over 29. Okay, so please follow this format. Call this thing with the arc theta. It can be written with a -1 also, right? Same thing. So call this theta, which ultimately means I'm trying to find a tangent of theta. Okay, so theta is arc sine of 20 over 29. Rewrite it so it doesn't say arc or the -1 thing, same thing. Sine of theta is 20 over 29. Do my SOHCAHTOA. Sine is opposite over hypotenuse. So the opposite is 20. Hypotenuse 29. Adjacent side, which we don't know yet, is x. Do my a squared plus b squared equals c squared. So x squared plus 20 squared equals 29 squared. Solve x squared plus 400 is 841. Subtract 400, x squared is 441. Take the square root, x is 21. So this is 21. Okay, and then I'm trying to find tangent of theta. So tangent is opposite over adjacent. So here's theta, opposite is 20, adjacent is 21. So tangent of theta is 20 over 21. All right, so the quiz I'm going to give you right now is almost exactly like that style. Okay, so do the same thing. You're going to have some trig function and an inverse trig function. Call that theta. Then say to yourself, what am I really finding now? Tangent of theta or whatever, right? Get rid of the arc, do your SOHCAHTOA, and go from there, okay? All right, any questions? Let me check the chat. Otherwise, take you into your groups. All right, so quiz time. So everybody get your cell phones out or be ready to do a screenshot. And as usual, I'll set you in your breakout rooms. And Mackenzie and Star will come around and help you as necessary.
Oh, so it's okay to help everyone during the quiz. I just
Yes,
haven't.
it's a group quiz, so it's open everything, open discussion. You're allowed to help each other out as much as you want. Okay, so here we go, please. Find the exact value of the tangent of arc cosine of 15 over 17. Draw a right triangle, show all your work. And when you're finished, same rules as usual on the Thursday quizzes. Put your first and last name, everybody else's first and last name, and submit it, and then we're done for the day. Okay, exact value of 10. This works almost exactly like the one I just showed you, okay? So do the same thing, hopefully you'll get it. Tangent of arc cosine 15 over 17. Call that theta, right? Write it without the theta, write it without the arc. And do your SOHCAHTOA and go from there. Okay, tangent of arc cos 15 over 17. Okay, I'll give you a few more seconds. Go ahead and get started, but I'll set up your breakout rooms and I'll put Star and Mackenzie in a room also. And Star and Mackenzie, if you're done with your group, then just come back to the main room and I'll put you in another group. Okay, I will assume that everybody has it now. In fact, I can probably even just type it in the chat. Also, that'll help you. Okay, so go ahead and get started. Let me set up your breakout rooms.